So in this last piece of the statistics unit, we're going to talk a little bit about standard deviation. Symbol is this small case sigma. And what the standard deviation does is it describes the spread of data from the mean. So if you were to find the average and then look at the numbers in the data set relative to that average, the standard deviation represents not necessarily the average distance away from that mean, but a calculated number that describes the distance away from the mean in average of each number. A larger standard deviation means there's going to be a greater spread. Smaller standard deviation means there's a tighter grouping. So if we look at this number set right here, each of these number sets has an average of 10. So obviously, in this case, there's not a lot of spread. In fact, this is 1 away from the average, this is 2 away from the average, likewise on the other side. So the standard deviation is somewhere between 1 and 2. This case has an average of 10, and every number is 10, so there is no spread from the mean, thus the standard deviation would be 0. We can do that one in our head. This one's a little bit different in that the distance away on each side from the average of 10 is 9. That doesn't mean the standard deviation is 9 because 10 is 0 distance away from the average. But that standard deviation will be somewhere between likely 8 and 9. In order to calculate the standard deviation, another story. Here's the equation, which is way over our head at this point. So obviously we're not going to calculate it this way. We could calculate it if we had some understandable terms. Basically, to do this, you take the difference of each number and the mean. So for instance, let's take a number set we've looked at before. In this case, the difference of the number and the mean is 9, and here the difference between the number and the mean is 9. And then you go back and you take each of those numbers and square them. All right, so in that case, you'd have 9 squared, a total of 4 times, and then 0 squared, which is 0. You'd add all those numbers up, and then you divide that by the total number of numbers. So you'd have whatever 4 times 81 is divided by 5, and then take the square root of that, and that's known to be your standard deviation. But again, that's a lot of work, especially for large data sets. So what we're going to do is our calculator has some powerful features in it, and calculating a standard deviation for a data set is one. So what we'll do is we'll take and plug this data set into our into our calculator. So here's a calculator, and what we'll do is we'll take first of all and press the stat button, and when I do that, it's going to take me to this screen. We're going to hit edit, so you could either hit enter because it's highlighted on edit, or you could hit the number 1. And here's a list of numbers. Unfortunately, it's not the list of numbers we need. You may not have any numbers in here, but let's say I want to get rid of those. I can either delete each of those numbers separately by hitting delete, or I could cursor up to the L1 button and then hit clear. Don't hit delete, because if you hit delete, you'll lose the whole list, and that kind of messes with your calculator. So after you've done that, bring that cursor down back into that column, and all those numbers will go away. And we'll just type in 4, hit enter, 6, hit enter, 12, hit enter, 17, hit enter, and 41, and hit enter. So now that data set is in that list, and notice that list is called L1. And what we're going to do now is I usually go back to the home screen, so I go second quit, or above mode says quit, and now I'm in my main screen. And then I'll go back to stat, and notice over here it says calculate. So what I'm going to do is I'm going to cursor over to calculate, and this first guy says one variable statistics. We're going to use that. And it says, where's my list? My list is at L1. Ignore the frequency list and go down to calculate and hit calculate. And what it does is it calculates a large series of numbers, some of which you don't need, but some of which we're going to take a look at. So here's your average, this X bar. We use mu for our average. All right, and that's 16. And then if you'll notice down here, well, here's our standard deviation, which is 13.3. Now, a couple other things we're going to notice. Let me write this in first. And that's our standard deviation. All right. Now, a couple other things we're going to find out. Down here, we notice, well, hey, here's our minimum value. If I keep going, there's the first quartile, there's the median, the third quartile, and there's the max. So basically, you have a box and whisker set of data right here. So now, I mean, you can at least use this to check some of the calculations you've been doing in the past. But I wanted to make sure you knew how to do it before I gave it to you on your calculator. So there we have it. Standard deviation calculated. Now, again, we're going to use that standard deviation and talk a little bit about some problems involving the understanding of that standard deviation. First of all, let's say we take a data set, 2, 4, 6, 8, 10, and then we were to add the same value to each number. So now that data set becomes 4, 6, 8, 10, and 12. And we want to know what happens to the average in the standard deviation. Well, let's do that on a calculator, just for the heck of it. Go back to our stat button, go to edit again, and we have 2, I'm just going to type over these, 4, 6, 8, and 10. And then what I'm going to do now is I'm going to go over to L2 and type in the other list. And the other list was 4, 6, 8, 10, 12. So I'll type those in. And in your head, you should probably be thinking about, okay, well, what's going to happen to the average in this case? Well, all the numbers have increased, so you'd think that average has got to increase, but by what? And then, again, those numbers have increased. What happens to the spread of data from the mean calculated? And we'll use our calculator to figure that out. So let's go ahead and do some calculations. All right. We'll go to, once again, we'll quit that. Back to our main screen, we'll go stat, calculate, one variable statistics, and we're going to do L1 first. So L1's here, we'll calculate that. We'll take all those numbers. So we have an average of 6 and a standard deviation of, what, 2.8. So now we'll go and we'll calculate the average and standard deviation for the second set. So we come back over to our calculator. I'm going to go stat, calculate again. We're going to go one variable statistics, but in this case we're not going to use L1, we're going to use L2. And if you look right above the number 2, you see L2, so I go second, L2. And now it's going to use that list to calculate my average and standard deviation. So I'll calculate that. And in this case, we have an average of 8. So as you can see, we now have an average of 8 and a standard deviation of about 2.8. So what we noticed is that if we take and add the same amount to each number in a data set, our average is going to increase by 2, but our standard deviation remains the same. Increased by the added number, standard deviation remains the same. So now let's do the same thing, except this time we're going to take and multiply by the same number. So again, what do you think is going to happen? Let's go ahead and use our calculator to figure that out. So as a reminder, we go back to stat, go to edit, and notice I've already changed things. Just type over the numbers that were in L2, And there you have it. We already know the standard deviation and the average for the first set. We can get that from our last example. Now we're going to calculate this average and standard deviation. So again, hit stat, calculate the one variable statistics. We're going to do that for L2. That's still in the list from last time. So we go ahead and do that. And you can see now we've got a new average and a new standard deviation. And that average was 12, and our standard deviation was 5.6. So notice something different happened here. We're multiplying by 2, and you'll notice that average actually multiplies by 2. And you'll also notice that in this case, because that spread away from that number got bigger, it also increased the average distance away. Whereas before, when we added a number to that, those numbers were relatively in the same place, just 2 higher. Now these numbers are spread out further, and so standard deviation is multiplied by 2 as well. So again, both the mean and standard deviation increase by the multiplied value when we multiply each number by the same value. We've got 2 graphs given to you, and within those graphs I give you the average. And we want to try to talk about which graph would have the higher standard deviation and why, or would those standard deviations be the same? So let's investigate that a little bit. Says the average here in this set is about 1.9, which is roughly right around here. The average here is about 2. Okay, and we want to know where the data has a bigger spread from the mean. Now you'll notice in this case that both data sets only go between 1 and 5. However, these are frequency graphs or frequency distributions. There's a lot more numbers in this set than there are in this set. All right, and you'll notice that this has 6 numbers which are between 1, 2, 3 away from that average, while this set has only 3 numbers that are 3 away. All right, automatically this is pushing much further away. Likewise, I have 6 numbers 2 away, whereas in this case I only have 1 number 2 away. All right, so again, this is pushing those outer bounds distances up a lot more. So I'm going to say that B has a greater standard deviation. All right, so now we want to take a look at a different problem. You have a teacher giving 4 students a quiz, and the minimum score is obviously a 0. Maximum score for the quiz is a 20. We want to know what's the smallest possible standard deviation of scores. Well, that we've seen a problem like that, which was in the first slide we did today. Smallest standard deviation is going to be 0, and that's when all scores are the same. So the answer would be the smallest standard deviation is equal to 0 when all scores the same. We want to know, okay, well, how could your standard deviation be the largest as possible? And we've done a problem like this before already too. We've got numbers from 0 to 20. We want a number dead center in the middle of that, which is going to be 10. And we have 4 students, so we want 4 numbers, all right, that are going to be as far apart from each other as possible, with 10 being the average. So that would be a couple of 0s and a couple of 20s. All right, and that's what that data set would look like. So now we're going to use our calculator to calculate that standard deviation. So again, we go to our calculator, we hit the stat button, hit edit, If you need to clear any of your previous lists, I already did that, and I've plugged in my 0, 0, 20, and 20. Now we're going to quit, hit stat, calculate the one variable statistics, go to calculate, and you'll notice we have an average of 10, and the standard deviation is also 10. So again, average of 10, standard deviation 10 in this case. So here's another example. We want to look at 3 lists, state which is going to have the higher standard deviation, then go ahead and just use your calculator and calculate that just to get some more practice. So we want to know which has the standard deviation, in other words, which is going to have the highest spread. Clearly not this one. These seem to be spread out from a middle number somewhere around 71 up to 75, down as low as what, 65. So that's like a 5-6 point spread. All right, and this guy we've got somewhere in the middle is about, well, 79. 11 point spread here, 20 point spread here. Sandy's definitely got to be the guy with the biggest standard deviation. All right, and then we want to take and calculate the standard deviation for Sally, and we can do that pretty quickly because we know each score is the same, thus there's no variation from that average, and the average in that case is 70, therefore the standard deviation is equal to 0. Okay, so new problem. We have some people running a 100-meter race. The times are given below. These are in seconds with tenths of seconds. There's 3 different racers apparently, or 3 different races going on with different times, and we want to know which race is going to have the smallest standard deviation. In other words, which race seems to be grouped more tightly than others. All right, and average is going to be somewhere in the middle. You know that each of these races has a low of roughly 10.7, high of 13, and these appear to be almost symmetric around that average somewhere in the middle of those two. All right, which is probably about, oh, I don't know, 11.7ish maybe, say right around here. And it appears to be pretty evenly spread. All right. In this case, if 11.7 is our average, we have a couple numbers spread pretty far out, close to that, 13, or if I have 11.7 here, getting out to 13 is about 1.3 apart both ways. So those are pretty much as far out as you can get. In this case, there's a very tight grouping here. One number on the outside, couple numbers on the inside here, but this big grouping towards the center, I would say that race 3 probably has the smallest standard deviation. We could calculate it and it would probably come out that way. Largest standard deviation means has the greatest spread of numbers. Again, these are evenly spread for the most part. We have some close in, some close out. This, you have 2 close in, but the rest are pretty far out. I would probably say 2 has the largest standard deviation. And if we want to know what's a decent estimate for the standard deviation of race 1, well, again, if we said this is our average, this is less than 0.1 out, this is 2, 3, 4, 0.5 out on both sides, 0.6 out on both sides, and then this one is about 1.3 out. So, I mean, I can't say perfectly, but I'd say somewhere between, well, we said this was 0.5, this was 0.1, and this was further out. I'd say somewhere between like 0.5 and 0.8, somewhere between there. I mean, you're not going to be perfect, but you could, again, use your calculator to calculate that if you wanted.